Bill Nye, the science guy, he has been getting us pumped about the final frontier and all its mysteries for decades.
James Webb Space Telescope, people have been working on this for over 25 years. It was because, as the saying goes, they needed a lot of miracles.
Bill Nye, the science guy, has been getting us pumped about the final frontier and all its mysteries for decades. James Webb's BTC has been a project in the making for over 25 years. As the saying goes, they needed a lot of miracles. The James Webb Space Telescope has been a project in the making for over 25 years, and it required a lot of miracles to come to fruition. For decades, Bill Nye, the beloved science guy, has piqued our interest in the cosmos, making the vast world feel a little more accessible. Now that the James Webb Space Telescope is capturing amazing photographs from over 13 billion years ago, Bill's joy is apparent. Come with me today while we explore the vast, wonderful world of outer space. These pictures have the potential to revolutionize our understanding of the universe as well as our perceptions of life. The James Webb Space Telescope, already regarded as a viable successor to Hubble, promises groundbreaking discoveries. James Webb will go where no other telescope has gone before. To catch more photons, it needs a bigger mirror, something 7 times larger than Hubble. So what fresh discoveries are being made, and how does Bill Nye perceive these cosmic wonders? Let's look at the latest celestial disclosures. The creation of the James Webb Space Telescope, also known as Webb, is the result of years of hard effort by NASA scientists and engineers. The telescope was launched on Christmas 2021, and its deployment over the next few months was a painstaking procedure that went ahead without a hitch. The telescope was operational by late June 2022, and within days, scientists made incredible findings. Thousands of new galaxies, older and further away, began to appear. Some of these galaxies were found to be more than 150 million years older than the oldest galaxies observed by the Hubble Space Telescope. Webb's unparalleled ability to collect light from astronomical objects like exoplanets and developing stars enables it to reveal their compositions and motions across space. Bill Nye underlines that Webb's data has already begun to reveal the atmospheric makeup of planets hundreds of light-years away, implying that they may be capable of supporting life as we know it. The Hubble Space Telescope recorded one of the most iconic images of the Eagle Nebula, known as the Pillars of Creation. These towering clouds of gas and dust, which are the centers of intense star formation, have long captivated astronomers and the general public alike. While Hubble's visible light photographs reveal the beautiful clouds around the pillars, the actual process of star formation within them was veiled. The James Webb Space Telescope, with its infrared imaging capabilities, has pierced the clouds to expose what lies beneath. Webb's photos show protostar clusters, which are enormous clouds of dust and gas many times larger than our solar system, forming tiny red dots against the pillar's murky backdrop. According to Bill Nye, protostars are stars in their early phases of formation. At this time, these young stars are not yet devouring hydrogen. However, as more material is sucked into their centers, they become denser and finally reach a critical point where hydrogen burning occurs, causing the star's temperature to rise to approximately 2 million degrees Celsius. Different colors were utilized in the illustration to depict the infrared wavelengths, which are mostly invisible to the human eye. The blue parts of the image are actually red. The wavelength of the hues in the image rises with radiation, with the red sections, such as the protostars, emitting radiation at a wavelength that is approximately 6 times that of the human eye. According to Bill Nye, this image not only demonstrates Webb's infrared capabilities but also sheds light on the birth of stars like our own Sun. The search for exoplanets, or worlds outside our solar system, has been one of modern astronomy's most exciting endeavors. Since the first exoplanets were discovered in the 1990s, the field has proliferated, with over 3,000 confirmed exoplanets catalogued to date. However, the issue is not simply discovering these faraway worlds but also seeing them. Direct imaging of exoplanets has proven to be one of astronomy's most difficult challenges, with only approximately a dozen exoplanets successfully observed. This is largely due to the enormous distances involved and the overwhelming brilliance of their parent stars, which frequently outshine the planets by a factor of billions. Most exoplanets are detected indirectly, such as through the transit method, which detects a slight dimming of a star's light as a planet passes in front of it. However, the landscape of exoplanet research is fast changing due to the groundbreaking capabilities of the James Webb Space Telescope. Webb, which was launched with the promise of altering our understanding of the cosmos, has exceeded expectations. In September, the James Webb Space Telescope made history by capturing its first direct image of an exoplanet, a big step forward in our ability to study these faraway worlds. The exoplanet is HIP 65426b, a massive gas giant discovered in 2017. Unlike many exoplanets identified earlier, Webb observed HIP 65426b directly with its advanced arsenal of telescopes. To accomplish this, scientists used Webb's coronagraphs, which are instruments designed to filter out the bright light from the exoplanet's host star, allowing the dim light from the planet itself to be identified. The telescope's exceptional sensitivity, paired with powerful infrared cameras and a variety of filters, enabled it to capture an image of this distant world with incredible clarity. HIP 65426b is an exceptional planet in many ways. It is almost 12 times the size of Jupiter, making it a true behemoth among gas giants. Furthermore, it orbits its host star at an incredible distance, 100 times that of Earth and the Sun. HIP 65426b's enormous separation from its star made it a good target for direct imaging, as the planet is far enough away from its star to be identifiable even with current equipment. The successful imaging of HIP 65426b is more than a technological accomplishment, it heralds a new age of exoplanet exploration. By taking a direct view of this faraway world, Webb displayed its ability to investigate exoplanet atmospheres, compositions, and maybe even weather patterns. Data collected from HIP 65426b has already begun to disclose previously unknown characteristics, providing insights into the genesis and development of gas giants in our galaxy and beyond. However, arguably the most intriguing aspect of this discovery is what it means for the future. HIP 65426b is only the beginning. The James Webb Space Telescope is poised to discover a treasure trove of exoplanets, many of which may lie in the habitable zones of their stars, the regions where conditions may be ideal for life to exist. The discovery of water vapor clouds indicates that the planet's atmosphere is more complicated and dynamic than previously imagined, with layers of varied opacity that may influence how light is absorbed and emitted. The consequences of this discovery are profound. For starters, it has spurred experts to re-examine both Webb telescope data and previous observations to better explain the apparent discrepancies. This re-evaluation process is critical because it may lead to new models of atmospheric behavior for hot Jupiters like WASP 96b, where extreme temperatures and radiation from the host star might result in unique and complicated atmospheric phenomena. WASP 96b is a fascinating world. It is classified as a hot Jupiter, a type of exoplanet that is roughly the size of Jupiter but orbits much closer to its star, resulting in extremely high surface temperatures. WASP 96b is almost the same size as Jupiter but has half the mass, making it far less dense. It orbits its parent star every 3.4 days, putting it in an environment with temperatures exceeding 1000 degrees Celsius. Despite the presence of water vapor in its atmosphere, the planet's searing circumstances make it improbable to support life as we know it. However, the discovery of water vapor on WASP 96b is significant because water is an important signal in the hunt for potentially livable environments. One of the most significant advantages of the James Webb Space Telescope is its capacity to see the universe in infrared light. Unlike visible light, which is obstructed by dust and other cosmic debris, infrared light can pass through these barriers, revealing hidden objects and structures. This capability allows Webb to peer into regions of space that were previously inaccessible, providing new insights into the formation of stars, galaxies, and planetary systems. As Webb continues to explore the cosmos, it promises to uncover even more secrets, deepening our understanding of the universe and our place within it.